Hello and welcome back to the channel Science, Maths and Engineering. Today we are going to solve the fifth and final part of this mechanical engineering paper, the examination for which was conducted by the Directorate of Technical Education Assam for the post of Assistant Professor in 2020. So let's get started. This is a pie chart describing the number of questions that were asked from GATE, previous year GATE question papers, and you can have a look to it. So let's get started. Question 81. For the given statements, 1. Mating spur gear teeth is an example of high pair, and 2. A revolute joint is an example of low pair. Indicate the correct answer. A. Both 1 and 2 are false. B. Both 1 and 2 are true. C. 1 is false and 2 is true. And D. 1 is true and 2 is false. So the answer is see, mating spur gear teeth is an example of higher pair. Okay, and there is a line contact. Again, revolute joint is an example of lower pair. So it has a surface or area contact. So our both 1 and 2 are true. So next question. A single degree of freedom system having a mass 1 kg and stiffness 10 kilonewton per meter initially at rest is subjected to an impulse force of magnitude 5 kilonewton for 10 to the minus 4 seconds. The amplitude in millimeter of the resulting free vibration is, so the answer is C. The impulse force creates a momentum in the system. Now momentum is equal to what? Force into time. So which is equal to m into u minus v minus u. So force into time is what? 5000 into 0.0001, that is 10 to the minus 4. So which is equal to initial velocity u was 0, mass is 1, so v becomes 0.5. Now we have what? Half of mv square is equal to half of kx square. So it is kinetic energy and this is energy of the spring. So from here we get that the deflection of the spring x is equal to 5 millimeter. So the amplitude of the in millimeter resulting free vibration would be 5 millimeter. Next question. The major difficulty during welding of aluminium is due to, so the answer is, see, the major difficulty during welding of aluminum is due to its high tendency to oxidation. Okay, so it becomes aluminum oxide, so we find it much more difficult for welding. Okay, so we can use some inert gases so that we do not, it doesn't form aluminum oxide. Next question. For an incompressible flow field V, which one of the following conditions must be satisfied? So the answer is the continuity equation for any fluid is del rho by del T plus divergence of rho V, which is equal to 0. Now, incompressible fluid, so rho is constant. So we have del rho by del T is equal to 0. So we have divergence of rho V is equal to 0. Now rho is constant. So we have divergence of V is equal to 0. Next question. Option D. A brick wall K is equal to 0.9 watt per meter Kelvin of thickness 0.18 meter separates the warm air in a room from the cold ambient air. On a particular windy day, the outside air temperature is minus 5 degrees centigrade and the room needs to be maintained at 27 degrees centigrade. The heat transfer coefficient associated with the outside air is 20 watt per meter square Kelvin. Now neglecting the convective resistance of the air inside the room, the heat loss in watt per meter square is, so we need to find out the heat loss. So the answer is, see, here we have H is equal to 20 watt per meter square Kelvin, and this is minus 5 degrees centigrade. On the other side, is 27 degrees centigrade. This is 0.18 meter is the thickness, and K is 0.9 watt per meter Kelvin. So our resistance here would be L by K, that is 0.18 divided by 0.9. So we get 0.2 meter square Kelvin per watt, and R2 is 1 by H. This one, so it is 0.05 meter square Kelvin per watt. The total heat resistance is equal to 0.25 meter square Kelvin per watt. So rate of heat transfer is equal to Q is equal to T1 minus T2 by R total, so which is this 300 Kelvin, this is 268 Kelvin divided by 0.25, so which is equal to 32 by 0.25, so 32 into 4, that is 128 watt per meter square. So next question. In the mechanism given below, if the angular velocity of the eccentric circular disk is 1 radian per second, the angular velocity in radian per second of the follower link for the instant shown in the figure is, we need to find out the angular velocity of the follower link. Okay, so the answer is, see, we have this rotation, this is 5, this is 45, and this is 25 is given. Okay, now we construct OB here perpendicular to this link AB and CD perpendicular to OB. Now this triangle ABO is similar to the triangle CDO. So CD by AB would be equal to CO by AO. So CO is 5 and AO is 45 plus 5, so it is 50. So CD by AB is equal to 1 by 10. Now in triangle OAB you see AB would be equal to OA square minus OB square. So from here we get AB is equal to 43.3 millimeter. Next, if we see that CD would be equal to 10, CD would be equal to AB by 10, so which is equal to 4.33 millimeter. Now, velocity of B is equal to velocity of D. Now, velocity of this D would be equal to what? CD into this omega. Omega is how much is given? It is given as 1 radian per second. So, our VB is equal to 4.33 millimeter per second. So, our omega AB, this thing, omega AB would be equal to VB by AB. So, it is equal to 4.33 divided by 43.3, which is equal to 0.1 radian per second. So, next question. A machine element is subjected to the following biaxial state of stress: sigma x equal to 80 megapascal, sigma y is equal to 20 megapascal, tau xy is equal to 40 megapascal. If the shear strength of the material is 100 megapascal, the factor of safety as per Tresca's maximum shear stress theory is, so the answer is C. You know this, sigma x, sigma y, tau xy, you know. Now shear strength of the material is given. As per Tresca's maximum shear theory, we have tau max would be equal to half of sigma 1 minus sigma 2, which is equal to half of root over sigma y minus sigma x whole square plus 4 tau x tau whole square. So 4 tau xy whole square. So from here we get tau max will be equal to half of 20 minus 80 whole square plus 4 into 40 square. So from here we get it is 50 megapascal. Now factor of safety would be equal to material strength divided by shear stress. So material strength is 100 and maximum shear stress here is 50. So factor of 50 is 2. So next question. During a TIG welding process, the arc current and the arc voltage are 50 ampere and 60 voltage respectively when the welding speed was 150 millimeter per minute. In another process, the TIG welding is carried out at a welding speed of 120 millimeter per minute at the same arc voltage and the heat input to the material, so the weld quality remains the same. Now the welding current in ampere for this process is, so this is a problem from TIG welding. Okay, we are given the current and the voltage for a particular welding speed, and for another one we are given the welding speed, we have the same arc voltage, so and the heat input to the material is same. Okay, so we need to find out the current. So the answer is, see, the heat transfer factor in TIG welding is F1 is equal to 0.7. So the rate of heat used for the first welding is R of HW1 is equal to F1 into I1 into E1, so which is equal to 2100 joule per second. Now R of HW2, which is equal to the for the second one, which is 0.7 into I2 into 60, so which is 42 I2 into joule per second. Now heat input to the material is the same. Okay, so the heat input is same, so which implies the heat input is given by RHW1 divided by A into V. So using this equation, we get that our current would be equal to 40 ampere. Okay, so next question. Consider massless rigid rod and small oscillation. The natural frequency in radian per second of vibration of the system shown in the figure is, so of the system we need to find out the natural frequency. So the answer is, see, if suppose there is a small deflection, okay, theta in this rod in the vertical plane, so deflection of the spring x would be equal to this theta is here suppose, so then it will be r theta is this deflection, right? Now spring force F would be equal to r theta into kx, so r theta into k. Next, the equation of motion can be written as this moment of inertia into theta double dot, so the angular acceleration would be equal to minus r into f. So from here we get it is equal to minus r square theta into k. Now I moment of inertia of this one would be equal to mass into twice r whole square. So from here we get it is equal to 4 mr whole square. So what we have from this equation is that 4 mr square theta double dot plus r square theta k is equal to 0. So theta double dot will be equal to, so theta double dot plus k divided by r square is removed, so k by 4m theta is equal to 0. No, so our omega n square would be equal to 4 by k by 4m. So our omega n would be root over k by 4m. So which is equal to 400 by 4. So it is 400 by 4 radian per second. Next question. A spur gear with 20-degree full depth teeth is transmitting 20 watt at 200 radian per second. The pitch circle diameter of the gear is 100 millimeter. The magnitude of the force applied on the gear in the radial direction is, so the answer is C. So this is how it works. So these are the forces that are there, and this is the angle. Okay, so our power P is 20 kilowatt, so it is 20,000 watt. Angular velocity is 200 radian per second, and piece circular diameter is 0.1 meter. Now we know P is power is equal to T omega, so T is equal to P by omega, so it is 200 Newton meter. Now T is equal to PT into R, so PT would be T by R, so we can write it as 2T by D, since D is equal to twice R. Okay, so from here we get it is 2000 Newton. Now tan of alpha, if you see here, tan of alpha is what? PR by PT. So from here we get PR is equal to, this one is tangential, one is radial. So PR is equal to PT into tan alpha, so which is equal to 0.73 kilonewton. So our question that the magnitude of force applied on the gear in the radial direction is, radial direction is 0.73 kilonewton. Okay, next question. Two large diffuse gray parallel plates separated by a small distance have surface temperatures of 400 Kelvin and 300 Kelvin respectively. If the emissivities of the surfaces are 0.8 and the Stephen-Boltzmann constant is 5.67 into 10 to the minus 8 watt per meter square Kelvin to the power 4, so this we need to remember because it is not given in all questions. The net radiation heat exchange rate in kilowatt per meter square between the two plates is, so the answer is, okay, from Stephen-Boltzmann law we know that the energy due to radiation is given by E is equal to sigma, that is Stephen-Boltzmann constant, into T to the power 4, where T is in Kelvin. Okay. Now, if we have emissivity is also there, so we know that E is equal to emissivity epsilon into sigma T to the power 4. Without emissivity, it is for a black body. With emissivity, it is for a gray body. Okay. So, therefore, E net would be equal to sigma into epsilon 1 T1 to the power 4 minus epsilon 2 into T2 to the power 4. Here, epsilon 1 and epsilon 2 are equal, so we can take it as epsilon. So, is equal to sigma into epsilon into T1 to the power 4 minus T2 to the power 4. So, sigma is given, epsilon is 0.8 and T1 is 400 and T2 is 300 Kelvin. So, from here we get E net is equal to approximately 0.79 kilowatt per meter square. Next question. A resistance capacitance relaxation circuit is used in an electrical discharge machine, that is EDM. The discharge voltage is 100 volt. At a spark cycle of 25 microsecond, the average power input required is 1 kilowatt. So the capacitance in microfarad in the circuit is, so this is the problem of the EDM, electrical discharge machining. So the answer is, see, we know that the energy released per spark is given by half into the capacitance into the discharge voltage square. Now, power input would be equal to energy released per spark divided by the time taken per spark. So, our power becomes half of C into Vd square divided by T. So, what is our C then? C is equal to 2 of power into time divided by Vd square. So, from here we know that power is given already 1000 and time is 25 microsecond. Then discharge voltage is 100. So, we have it is as 5 into 10 minus 6 farad, that is 5 microfarad. Okay. So, option B is the correct answer. Next question. The principle of material removal in electrochemical machining is, so the answer is, see, electrochemical machining is considered as the reverse of electroplating with some modifications. So it is governed by two laws of Faraday, that is, the amount of chemical change produced by electric current, that is, the amount of any material dissolved or deposited is proportional to the amount of electricity passed, and number two, the amount of different substances dissolved or deposited by the same quantity of electricity are proportional to their chemical equivalent weights. Okay, so these are the two laws of Faraday that governs the electrochemical machining. So option D is the correct answer. That is Faraday's law. So next question. An air-centered diesel cycle consists of the following processes. From 1 to 2, air is compressed isentropically. From 2 to 3, heat is added at constant pressure. From 3 to 4, air expands isentropically to the original volume. And from 4 to 1, heat is rejected at constant volume. Now, if gamma and T denote the specific heat ratio and temperature respectively, the efficiency of the cycle is, so the answer is, see, so this is the diesel cycle. The PV is given, so this is the TS diagram. So the efficiency of the diesel cycle is given by QS minus QY by QS. That is, here our what is the heat added here minus what is the heat rejected here at 4.1 divided by what is the heat added at this. So this is how much heat added divided by added minus the rejected one. So from here you get Qs is m into Cp T3 minus T2 minus m into Cv, this one, T4 minus T1 divided by m into Cp T3 minus T2. We get this 1 minus Cv by Cp and then T4 minus T1 divided by T3 minus T2. So Cp by Cv is gamma, so we have 1 minus 1 by gamma and T4 minus T1 divided by T3 minus T2. So our option A is the correct answer. Next question. A rigid horizontal rod of length 2L is fixed to a circular cylinder of radius R. As shown in this figure, this is radius R, and so this horizontal rigid rod of length 2L is fixed. Okay. Vertical forces of magnitude P are applied at the two ends as shown in this figure. So this is P and this is P. Right? Shear modulus for the cylinder is G and the Young's modulus is E. So the vertical deflection at point A, so at this point A, what is this vertical deflection we need to find? So the answer is, see, let y be the vertical deflection. So once we twist, so let y be the vertical deflection. Okay. Now we know theta is equal to TL divided by Gz. Okay. Now what is T here? T would be equal to P into twice L, right? So 2PL is the torque. Then J for the cylinder would be equal to, J is what? Polar moment of inertia, so it is pi by 32 dt to the power 4, which is equal to pi by 2 r to the power 4. So from here we have theta is equal to 4PL square divided by pi g into r to the power 4. Now y is equal to how much? Y is equal to theta into this length, that is L, right? So y is equal to our theta into L. So we have 4PL cube divided by pi into z r to the power 4. So our option C is the correct answer. Next question. For a Pelton wheel with a given jet velocity, the maximum output power from the Pelton wheel is obtained when the ratio of the bucket speed to the water jet speed is, so the answer is, so this was asked previously in two gate questions. Okay. So the answer is, you see, when the power produced is maximum, the efficiency is maximum. Now the efficiency of a Pelton wheel is given by this equation. Now for maximum power, this efficiency divided by du should be equal to 0. So this is the bucket speed. So from here we get that our V1 minus 2u would be equal to 0, or u by V1 would be 0.5. So answer is 0.5. Next question. A car is moving on a curved horizontal road of radius 100 millimeter, so 100 meter, with a speed of 20 meter per second. The rotating masses of the engine have an angular speed of 100 radian per second in clockwise direction when viewed from the front of the car. The combined moment of inertia of the rotating masses is 10 kg meter square. The magnitude of gyroscopic moment in Newton meter is, so the answer is, see, if radius is given, velocity is given, now angular velocity would be equal to v by r, so it is equal to 0.2 radian per second. Now angular speed is 100 radian per second, which is already given. Now moment of inertia I is 10 kg meter square. Therefore, the magnitude of the gyroscopic moment would be equal to P is equal to I into omega B, so which is equal to 200 Newton meter. So next question. A weight of 500 Newton is supported by two metallic ropes as shown in the figure. Find the values of tensions T1 and T2. Okay. So the answer is, you see, using Lami's theorem, we have T1 divided by sine of 120 degree would be equal to T2 divided by sine of this angle, which is 360 minus 210, that is 150 degree. Okay, and which is also equal to 500 divided by sine of 90. So we have T1 is equal to 433 Newton and T2 is equal to 250 Newton. So next question. A hinge gate of length 5 meter inclined at 30 degree with the horizontal and the and with water mass on its left is shown in the figure. So this is the water mass, this is the hinge gate. Okay. The minimum mass of the gate in kg per unit width is perpendicular to the plane of paper. Okay. Required to keep it closed is, so water is going to escape, but because of the weight it is being closed. So we need to find out the minimum kg per width of this gate. So the answer is, see, the center of gravity of the plate AB lies at midpoint of AB, say at G. Okay, midpoint of AB. So AG would be equal to 2.5 meter then. Okay, now H bar is AD, so which is equal to AG sine 30 degree, which is equal to 1.25 meter. Now pressure force is given by F is equal to rho G A into A square. So from here we get, okay. Now width W is what? 1 meter. Length is 5 meter. Rho is 1000 kg per meter cube. Rho and density of water. Area is 5 meter square. Okay. So per unit we are saying, so we are getting 1. Unit is 1, right? So F is equal to rho G into A square. So it is equal to 61312.5 Newton. Now let the center of pressure lie at P. So the vertical distance A star is equal to A star is equal to AE, right? Center of pressure here is at P. Okay. So A star is equal to H bar plus Ig into sin square theta divided by A into H bar. So Ig we already know is BL cube by 12, so we know it as 10.41. So A star will be equal to 1.25 plus this part, so which is equal to 1.667 meter. Now taking the moments about A, see this point A, what we have is that F into AP, this F into this distance AP is equal to W into dg. So F into AP is equal to W into this time dg. So this is anti-clockwise and this is clockwise. So it will be balanced. So from here we get that W would be equal to 94396.769 Newton. Now W is what? Mg. So M would be equal to then this value divided by 9.81. So our mass would be equal to 9623 kg. Right. Okay. So next question. The precedence relations and duration in days of activities of a project network are given in the table. The total float in days of activities E and F respectively are. So this is a problem of CPM, and here the activity is given, the predecessor is given, and the duration for the activity is given. So we have to draw the critical part here. Okay, so this network is represented here. See, A takes 2 days, so earliest we can get it, and 2 days. C takes 2 days, so earliest we can get it 4 days. Next from here, F takes 4 days. Okay, then E takes 2 days. Now if we see this route, if you can see it, B takes 4 days, so earliest is 4. D takes 3 days, so see here it was 2 plus 2, earliest 4 days would have been there, but here already 4 plus 3 7, so earliest it will take 7 days. Okay, next from here plus 5, so it takes 12 days. So if we see this part takes the longest time, so this is the critical part. Okay, next you can again check 2 plus 2 4, 4 plus 4 8, then 2 plus 2 4, 4 plus 2 6, 6 plus 5 11, 4 plus 3 7, 7 plus 5 12. So this is the critical 5. Let's see, maximum time 12. So earliest also 12, latest also 12. Now if you go back here, so earliest would be minus 5, so 7, and latest is also 7. If you go back this way, then earliest it is 4, but latest you see it should have been 8 there, but here you see earliest 7, latest 7, so minus 5 2. So earliest it becomes 4, but latest it becomes what? 7 minus 2 is 5. So we have one extra day then. So again 2 days here, so latest is 3, earliest is minus 2, so it is 2. So that way it comes. So now the total float in days of activity E. Activity E is this one, right? So how much it takes? You see, 7 days is the latest time it should finish. Now earliest time to start is 4 plus 2 days it requires, so it has a float of 1 day. Okay, latest time is 7, earliest time here is 4, so after 4 days you can start activity E, and latest we have 7, but activity E takes 2 days, so 7 minus 4 minus 2, so we have 1 day for float of E. Okay, next total float in for activity F. Activity F we see earliest we require is 12 days, sorry, latest is 12 days here, and here earliest is how many days? 4 days. Now 4 days is required for activity, so it will be 12 minus 4 minus 4, so we get 4 days. So the float in days for activity F would be 4 days. Okay, similarly if we see any way in this critical part there is no float for any activity, like activity D, if we see latest is 7, earliest there is 4, so 7 minus 4 3 minus 3, so 0, so we have no float here. For activity suppose C, we see latest is 5 days, earliest is 2 days. So 5 minus 2 minus 2, we get 1 day. Okay. So this is how it is done. So with this, we have come to an end of this paper. So we will see you with more papers soon, and we are trying to bring more papers frequently. So stay tuned with the channel and see you in the next one.